Hi, my name is Spencer. Once again, I'm a fourth year here at Columbia. In this video, I'm going to talk about data structures and objects. So R is super powerful. It can load extremely large data sets, do complicated analyses, and make highly useful visualizations. However, it only does what we actually tell it to do, using the data or objects that we give it. For that reason, we need to define objects while we're working in R. This lets it know to what we are referring, and so that we can actually manipulate those things. You've actually seen this multiple times in the previous videos. When we imported a CSV file, we stored it into a data frame object. Here, I had the county's DF object that was defined as the results of the read.csv function from this file. Similarly, I can also manipulate this object by doing different commands to it to define it in different ways. So if I run this command, if I want to refer to that data frame, I just have to type in counties DF. So now that we have an object called counties DF, we can do stuff to it depending on what type of object it is. This is a data frame, which is probably the most useful object you'll work with in R during this class. But I can also define even simpler objects than that. I can define a variable as a number, or a string, or even a special type of list called a vector. This relies on the assignment operator, which looks like this little arrow. It tells R to store whatever is on the right side of the arrow into an object that has the name on the left. So here, my number is assigned the value of this number divided by 50 plus 2 times 11. My string is defined as this quoted example string. My vector is defined as using C, which defines a vector, all of these lists of fruit. If I run this command, and I want to refer to these objects, all I have to do is type in their names. So if I call my number, it'll give me the result from when I had defined it, in this case, 2022. If I want to see what my string is, I can run that, and it's just the example string that I had given. If I want to see my list of fruit, I can run my vector, and you can see that it is referring to the same object. Often, you'll have defined a lot of objects while you're working in R. R is very literal. You need to match the exact spelling and case of your object so that R knows exactly what you need. Using helpful and explanatory names will make your life so much easier. So here I type my number, but I use a capital N instead of a lowercase n that we had seen in the previous example. If I try to do this, it'll return an error. It doesn't know what my number is. It can't piece it together using context clues. So you need to make sure you call it with the proper case. Often, you can actually use the tab completion to see your options and ensure that you are typing it correctly. So if I type my and then press tab, I can see all three of my options. If I want to see my number, I press enter, and I can just run that command and it'll properly populate the information. If you want to see a list of all of the objects you have in your current R session, you can use the ls command as I show here. When I do this, you can see that there are 4 different objects. There's the county's data frame, my number, my string, and my vector. Different functions and packages create many different types of objects that will have different properties and associated commands to use. The rest of this video will go through the most common types of objects you may encounter, including simple variables, vectors, matrices, data frames, and lists. Simple variables are what you've already seen in this video, just a variable that contains a single value. Here I define my variable as cats. Then I define a new object, name it whatever you want variable, and give it a value of 40. Variables contain all sorts of different types of data, and that'll be explained in the next video, which goes into data types, which is different than data structures. If you want to see what the value of the variable is, as I've shown before, just type in the name of that variable. You can also use the name of this variable dynamically to enter things in other settings or contexts. Here, I know that my variable refers to cats, and so I can say that I'm allergic to cats without ever typing the word cats. It just calls for the value of my variable. The next data structure is vectors. These are one of the most essential types in R. They can only contain one type of a variable, whether it's all numbers or all strings or all logical values, but their list-like structure allows for many complex actions to be done to them. So here I define a number vector, which is just a set of numbers. Here I define a textual vector, which just takes a bunch of words related to this course. And just like any other ordinary variable, I can see what exactly a vector's object's values are by using its name. The thing is, we can start to do a lot of fancier things to a vector, such as referring to a specific value within the vector. Here, I want to call the third value of the vector by typing the name of my vector and specifying within these brackets the number 3. This tells me that I want to go to position 3. We saw above that my text vector had all of these values, and I go to the first, second, third option. When I run my command, I should see social determinants of health. Indeed, we see social determinants of health, knowing that we've correctly identified this component of the vector. We can also sort vectors. So in our number vector that we had defined above, we may want to sort it into ascending, descending, or whatever other sorting mechanism we want to specify. Here, I sort it so that it is ascending, and you can see that it's all the same numbers now in increasing order. Similarly, I can find maxima, minima, and averages of my vectors just by using simple commands. 7 is the maximum, 1 is the minimum, and 4.57 is the mean of this vector. Matrices are used to store multi-dimensional grids of numbers specifically. Certain functions take these as inputs or use them internally to speed up calculations. For example, I'm going to define a 3x3 matrix that just has the numbers 1 to 9. Here, I define it as my matrix. I use the matrix command to let R know that I'm specifying a matrix. Here, I give all of the values that I want to include, which are the numbers 1 to 9 as a vector. I specify that I want 3 rows by using the n rows parameter. Then I specify that I want 3 columns using the n-col parameter. When I run this, I can see that I have a matrix that's 3 by 3 with all of these numbers. You may notice that the order is not what you expected, but you always have to be careful about how you're defining your rows and columns when you define a matrix. Now, just as we had been able to call values from our vectors, we can also call values from our matrix. The format for this is the name of your matrix, your hard bracket, and then the row number, comma, column number. This example specifies my matrix goes to the third row in the first column. If I go to the third row in the first column, I should see the number 3. You can also pull out entire rows or columns if you like. For example, if I want row 3, I can say, go to my matrix, use the bracket, go to row 3, and then just put a comma and say, I want all the columns. I don't need to specify a specific column. Similarly, I could go to my matrix, skip the row part of my destination, and just say comma 2, which would say, give me everything in column 2. When I run this, you can see that row 3 is 369, as we saw above, and column 2 is 456, as you see above. The most important data structure you'll use is the data frame. It is the tabular format that you typically think of for storing data. You've seen plenty of examples of this thus far, including the counties DF we imported earlier. Typically, each horizontal row is one observation or data point, while each vertical column is a variable. You can specify empty data frames using the data.frame command as well. Here, I'll view the counties DF data frame. Again, notice the capitalization to use the command view. Data frames have names for their columns, not just numbers. That separates them from matrices. This is how you can see all the column names in a data frame. You use col names, parentheses, and then the name of the data frame object that you're referring to. When I run this command, you'll see that county is column number 3. Column number 4 is deaths, column number 5 is years of potential life lost rate, and so on. All of the columns will be defined when I use this. Now, you can refer to a specific column by using the data frame $ column name format, or you could use the number that corresponds to it. Tab completion is really going to be your best friend for this. So let's say I wanted to create a vector that is defined as just the list of counties available in my data set. Here, I refer to my data frame, counties DF. I use the $ operator, which says look for a column name and then I type in the column name that I care about. If I run this command, it'll spit out all of the results for county names in my whole data set. As you can see, these are all of my options. Notice this comes out as a vector, so all of the commands you learned about manipulating vectors, you could also use to manipulate this, depending on the actual data types that you have. As I said before, you can refer to a column also by its column number. So in this case, if I want to call the third column, which we had seen was the county column, I could say counties DF, use the brackets, and say I want all rows, comma, third column only. If I run this, it's the same exact result as we saw above. If you want a specific row in the data frame, you can do that as well. Here, identify the 1,859th row, which corresponds to New York City, which, confusingly enough, is also a county. So I specify my objects, counties DF, use the bracket, 1859 corresponds to the row, and I want all of the columns. And you can see when I run this, I have New York, New York, and all of the information about New York County. If you want a specific value in a data frame, you can navigate it using a combination of both the $ and number formats. For example, if you wanted to know the percent of uninsured patients in New York City, you could do that by first specifying your data frame, using the $ and specifying the column as %.uninsured. In this situation, you've defined a vector, and you want the 1,859th value of that vector. If you pull that out, you will be able to see that that will give the uninsured rate in New York City. You can also specify it purely with numbers. We know that it is the 1,859th row, and percent insured is actually the 23rd column. Each one of these commands will give us the same exact result. I want to also draw your attention to the fact that when you pull out specific values in a data frame, you have to use double brackets so that R knows you're working with a data frame rather than a matrix. If I run these commands, you'll see that the uninsured rate in New York City is 6.14%, which is quite low compared to the rest of the country. If you want a table of values of a column in a data frame, you can use the table command. You can do cross tabulations where you construct tables across multiple categories as well. This shows how many observations there are for each state, counties plus one statewide value. I run the table command looking at just the state column in the counties DF data frame. Here you can see the number of counties in each of these states. Similar to data frames are something called tables. They're a more modern version of data frames that have easier printing and subsetting functions, and it's part of the tidyverse package. If you want to install it, you would have to install tidyverse, and then you can load it into your actual functioning code by using the library tidyverse command. Here, I'm going to just convert my counties data frame to a tibble and rename it a new object, counties tibble. I run this command, and I've now defined a new tibble. It doesn't look any different to you because Jupyter Notebooks already works with tibbles for the most part in its viewing software. If I wanted to get just a subset, tibbles are way more useful than underlying data frames built into R. Because it's tidyverse, I specify my object, I use the piping operator, and I say print n equals 10 rows and only 5 columns. When I run this command, I can now see I only have 10 rows and I only print out 5 columns. Once I've done that, I know that it's actually printing out what I want to see. The final data structure to talk about in this very long video are lists. They're the most general data structure. They're a list of literally anything you want. You could have a list that contains data frames, vectors, variables, or even combining them. It doesn't really matter. So here I define my list and I make it a list of a data frame, a number vector, and a matrix. If I run that, I can now refer to that my list object. To extract from the list, you can specify the number in the list you want to access. So if I want to get my number vector, which was the second thing in my list, I type my list, double bracket, and then 2. And when I run that, you can see that that returns us the number vector we had defined earlier in this video. I know this was very complicated, but you'll get more practice as you go throughout the videos. For now, Try to define a vector in the following order: the year you graduated college, your year of birth, when you graduated high school, and when you plan to graduate medical school. Then, using the sort command, try to sort it from earliest to most recent.